So if you're ready to hook up to this tutorial for the personal training, I would say you should just follow the link down below this training and join our Ekidel Mentorship Class. Okay, so thank you. Then go
Yeah.
to story 2, story 00, sorry. Story 00.
00.
Yeah, so 00 is your foundation
Okay.
level. Okay, so right then, before we go again, last time I didn't show you how to add story height. If maybe you have this like the headroom for the ground floor to be, let me say, 3.5 meter or 3 meters, and the first floor to be
Yes.
4 yeah. So to do that, just go to that building setout,
Do things set out. Okay.
then go to edit story, down, come down, edit story, yeah, edit story. So if you want to add your height now,
Uh-huh.
your height of building, you see that place called H, that tab after story called H.
Yeah.
Yeah, so you can add your value
Yeah.
there for your height. You can add the values there if you want to add
Okay.
values. But since I've already run this analysis, there's no need, because if you do it, it will cancel all what you have done before.
So I would have to reanalyze now.
But just leave it. But I don't want to show you, so that next one that you'll be doing, if you have different heights, you can come here and then change your height.
Yeah.
Then also this place showing first story button level at the, yeah, that
Yeah.
place. That place is called that's the place where you can impute your height of DPC height. As
Okay.
Yeah, as you all know, for normal building, most DPC they use 450, they use 600, and most times 750, depending if the terrain of the site and the road is too low. If the site is too low from the road, you have to have a higher DPC. That's what I mean. So
Yes.
it is
Mm.
from here they can add that your value of your DPC. Then for this place called foundation depth, you can leave it as default as that 1.1 or 1.2, because foundation depth is mainly known at the site during the construction, because you can give them the depth of the foundation here to be 1.2, but when they go to the site, they can find out, let me say, there is a pit somewhere which they will have to dig deeper or have to sandfill and all that. So with that, that depth that you gave them will not be okay. So normally it is always advisable to leave depth of foundation. You can just give them let me say 1.6, 1.8 and all that. But at site, they will now know the main depth of foundation of at least what they would like a dig. I don't know if you get
Mm.
me. Yeah. Okay.
Yes. 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 I get it.
Okay, so that place is just to put your DPC and the height. So next one when you're doing, you can put that first before you can now click on design, analysis and design. So just click on cancel. Then so on your story 00 now, to begin your foundation design, the first thing to do is to click on one of the columns. Just click on one of the columns, then right click any of them, right click, and then say insert pad base. So right now we are assuming that the soil bearing capacity of this building where this site is to be placed is a bit okay. Let me say is around 150 kilonewton per meter square. But
Uh-huh.
normally, before you must do your foundation design, you must have to get your soil test of that
Yes.
of that site. But right now we are just trying to assume. So let's assume that the bearing capacity of this soil of the soil is 150. So with that, we are going to use a pad foundation, because okay, I don't know if you have a pen and paper there.
Yeah. I do have.
Okay, so for your choice of foundation, when your bearing capacity is more than 100 kilonewton per meter square, and you're designing for a one-story building or for a two-story building, you should the first type of foundation that should come to your mind is a pad foundation. for a pad foundation. Then if it is for a 3-story building, you have a pad foundation and also have a ground beam, tied tying all the columns together. The same thing for a 4-story building. A pad foundation can still go with a ground beam if your bearing capacity is more than 100 kilonewton per meter square. Then once you enter a 5-story building, you should consider using a strip foundation so that it will be able to spread the load evenly. You should be thinking of using a strip foundation even if the bearing capacity is okay, is at least more than 100 kilonewton per meter square. Then once you enter into a medium rise building, which is from 6-story to 9-story building, even if the soil is okay above 100 kilonewton per meter square, you should be if it is for a 6-story building, you will still be considering using a deep strip foundation for a 6-story building. But once you enter to 7-story, 8-story, 9-story, let me say 8-story to 7-story, you should consider using a raft foundation, even if the soil bearing capacity is okay. But at 8-story to 10-story upward, you should consider using a pie foundation, because when the height of a building or the number of your story increases to at least more than 10-story, you have to use a pile foundation to be able to carry the load of the structure to a suitable soil and strata. Then when your bearing capacity is between 75 to between 75 to 100, that's for your bearing capacity. And even if you're designing for a 1-story building, you should consider using, the first thing that will come to your mind is pad foundation and also a strip foundation. Then if it is for a 2-story building, the same thing, pad foundation with a strip foundation. 3-story building, the same thing, pad foundation and strip. But from 4-story, you should consider using a wide strip. No, for that 3-story, you can use a wide strip foundation. There is difference between a strip foundation and a wide strip foundation. A strip foundation is just the ground beam alone, but a wide strip foundation has a beam and also has a footing. It's like a T. If you cut a section of a wide strip, it's like a T where you have the footing and then you have the beam. That footing of the wide strip is not a pad foundation. No, it is like a base for the strip beam. Then, once you check that your wide strip cannot be able to carry the load, or let me say there is a failure on the wide strip, you should now consider using a wrap foundation. So that is how the series goes. If you check for pad foundation and you see that the pad foundation is failing, or you're having a bigger size of pad footing, you should consider using a strip foundation. And if that is failing too, you should consider using a wide strip foundation before you now get to wrap foundation. Most people don't use to check all these. They'll just go ahead and go and use a wrap foundation for a building that would have meant to use just a wide strip foundation. What will happen is that if you don't use a proper foundation, yes, it will be stable, it is okay, but the cost of the foundation will be very, very more, because the cost of a wrap foundation is very, very high. And also for a pie foundation is also high. And if a client sees that for just 1-story building of just a small building, you're not giving him like a wrap foundation for a bearing capacity of 75 to at least 100, I think it's not nice. It's not nice because they will know that maybe you don't have enough experience or and all that. Then once your bearing capacity is lower than 75 kilonewton per meter square, pad foundation is no longer a choice again. Even if it's for 1-story building, you don't consider pad foundation again. Pad foundation only stops when the bearing capacity is either 75 kilonewton per meter square and above. But once the bearing capacity is below 75 kilonewton per meter square, you don't consider pad foundation again. what should come to your mind first is a white strip foundation. White strip foundation comes to your mind first. Then when that one didn't work, you can now go and use a mini raft foundation. And raft foundation consists of two types, either raft beam or just a raft slab. Then for the raft foundation, when you consider raft on beam foundation, if it didn't work, you now consider raft on slab, just raft on slab without beam. Now, raft on beam foundation is not that expensive when it comes to raft foundation compared to raft on slab alone. Raft on slab is very, very expensive. Most people call raft on slab foundation, they used to call it floating foundation because of how they are being constructed. Then when a raft on slab foundation fails, you now enter into pipe foundation. Pipe foundation is the last option for for a foundation design. Then when your bearing capacity is below 40 kilonewton per meter square, the only foundation you should think of is raft foundation and a pipe foundation. But pipe foundation, and you can only use a raft foundation for a bearing capacity below 40 kilonewton per meter square if it is for 1-story building, 2-story building, 3-story building, and 4-story building. From 5-story building, for that kind of bearing capacity, you should be considering using a pipe foundation, even if it will be a mini pipe of at least length of 10 meters or 7 meters, that is okay. Then when you're designing for a high-rise building are always building more than 10-story. Once your building is more than 10-story stories, like 10-story, it is now called a high-rise building. At that point, you should be expecting pipe foundation from at least 20 meters, 15 meters, or 18 meters in regards. Okay, so the reason why I took time to
Yes.
tell you these foundation types based on your soil bearing capacity, so that you will not waste your time if you see a bearing capacity of, let me say, 50 kilonewton per meter square. You know your time and go and use a part foundation first, because it will fail. Part foundation will fail at that kind of bearing capacity. So you should think of, first of all, to go for a raft foundation at that kind of bearing capacity. But once your bearing capacity is above 75, or let me say 75 upward, the first thing you have to try is a part foundation. Then if that is too much, like let me say, if that is too big or the size becomes too big, you now consider using a strip foundation or a white strip and all that sequentially. Okay, so for this case right now, we are assuming that the bearing capacity um of this of this site where the building is to be sited is 150 kilonewton per meter square. So right now, on that place where you're seeing allowable soil stress, you have to put in the value there as 150. Then the place where you see footing depth upward, footing depth, that
Mm-hmm.
place for a part foundation, the minimum footing depth is 250 millimeter. That's the minimum footing depth that you can assume. No, I'm saying minimum. So if we assume this now and there is
Yes, yes, I
failure,
get you.
if there is failure, we can choose to go for 300, but 300 is the most common because 250 is the minimum. So most people don't like using minimum because one of the column might be failing on that depth. So most people use 300 first as their own starting point.
Because it's
Yeah,
likely to fail if it's not the minimum.
yes, exactly. So you start with 300. Let's start with 300 first. So what you're going to input here is just these two values. Leave every other values as default. So once you come to this place, once you input your footing depth and then put in your bearing capacity, which is that 150 or any other value, then on this place where you're seeing your steel bars, maybe I have to choose your reinforcement. Let me see there. Click there. Let me see. You can see your steel bars there. Choose their place. Okay, now for a one-story building, which has a good, for a one-story building actually, the first thing that should come to your mind is the 12. I don't know. Okay, it's not checked
The
here.
Y12.
Okay, no, if it's not checked here, click on just cancel and go and assign it on your material property. So just cancel, then go and assign it for foundation reinforcement. So just cancel. Let's go and assign the rebars for foundation. Go to your analysis and then edit building design, sorry, yeah, that one. Then edit material, then go to your foundation. You can see foundation at your left hand side at the top. Your foundation floors, click there and choose your rebars for foundation. Use them that since it's a one-story building, just take only, you can take 12 minimum, then maximum 16, but in all we will only use 12. So uncheck all and just check only 12 and 16. Okay, then okay it, then close, close. Then try to save this thing, just save, click on save at your this thing there. Okay, then go back to the place again, click, just do it. No, like do the same thing again here, right? Click and say footing, insert footing. Okay, that's fine. Then input your values back, put in your footing depth of 300. Let's start from there. Then put in your bearing capacity, let's use 150. Okay, choose that place too as this. Now click on calculate at the top there. Now when you get to this place now, the first thing, so can you just bring this into the center? Let me be seeing everything. Okay, yeah, that's fine. So you can see the first thing to do is to click on square footing. Always assume a square footing first, except maybe you have some restriction at the edges. You cannot choose a rectangular footing. So check that place where it's called see square footing. Okay, now based on the load on that column, you can see that it has given us a footing size of 12 by 12, which is that LX and LY, as you can see there.
Yes.
Okay, now the checking to check here is to check for punching check. Now, punching check will only happen if your depth of footing, which is at 300, is not sufficient. You begin to have issues in your punching check. Now, as you can see that place called punching check. I don't know if you can see that.
Yes, I can see.
Okay, now for your path foundation to be okay, you can see that along all those checking, you'll be seeing okay there. All those things must be showing
Yes.
okay, and okay. If there is any failure around all this okay, that means that you have to go and increase your footing depth. So let us try it now. Just say okay, then make your footing depth to be 150. Let's see, so that you can be able to see when it's failing. Use 150. Let's see if that will pass, and then go to calculate. Now you can see it, right? So that's how it is. When your footing depth is not sufficient, this is how you will see failure. Now, if you say okay and then say okay again, this software will just give you your path foundation. Now, just try and say okay first, and then now say the final okay there, final okay at the top there. You see that it will still insert your path foundation for you, but that foundation is failing. So that's why I say most times, if you don't know all those checking, you will just be doing using software as it just give to you. So right now, go and increase your depth, because that depth of 150 is failing. So click back on that. No, click back on the right click and say properties. No, click on the footing itself. On the footing
itself, okay.
Then properties. Then go and change your depth to 300 and then calculate it back. Calculate back. Okay, now on this place now, no, hold on, go back there again. Now on this place here where you have now we have done the checking for the punching. Now there's also checking for this area called this AS required reinforcement area. Now if your spacing, now how to know that that your size of your reinforcement is not sufficient, once your spacing, this place showing 225, that is the spacing of the reinforcement. Once it is 100, it is not okay, because at least I would advise you use your minimum spacing to be 125. So once that value there shows 100,
Okay.
yeah. So once it shows 100, that means that the size of that bar is not okay to like carry the load. So you have to go and increase your size of bar from 12 to 16. That is only when you can increase your size of bar, when this place showing spacing is, let me say, 100 or below 100. Right? Okay,
Okay.
so now that we are having 225 at the spacing of reinforcement, so it is okay. So with this right now, we can now see that this is okay. So we can now click on OK and then click on final OK. Okay, just click on OK first. Okay, now just now click on the final OK. Okay, now the same procedure for the same columns, for all the columns. Now do the same thing for all the columns. Now once you have done the first setting, you won't set anything again. You just open, then say calculate. So click open now, just click that place now, insert part base. Now no more setting again, because you have already set the footing depth and the bearing capacity. So just go ahead and say calculate, then check your checking if it is okay. Check for point chain if it is okay, and then check for the reinforcement area if it is okay. So click on that.
Okay.
Okay, so you have to check.
It's
Always
a
check.
1 meter, this one.
No, then square it. Always square it. Click on square first. Yeah, always square. Then once you square, you check. Always check for this okay. Check for all this okay. They must be okay. Then check for your spacing of reinforcement if it's more than 100. Once it's okay, then you can now say okay, then okay again. Now, most people go as far as selecting all the columns and then go and now do it automatic. When you do that automatic, no, just say okay. Say okay, and the final okay. Now just zoom here now. Now try to select like 5 columns together. Let me show you what most people do. Just try to highlight a column, like 5 columns. No, you can just highlight. Click out, yeah, then not drag it. Click and then drag. Yes, fine. That's fine. Okay, now just now right click and say insert part base. Say insert part base. Yeah, that one. Now you can see that they're telling you create a typical footing. So if you say okay right now, or even if you didn't check that option, it will just insert the part base for you without you checking if the footing depth is okay or not. So just click on
Okay.
okay. Just click on okay, then you see what will happen. Click on okay, then click on calculate and then okay again. Okay it again. Okay, okay again. Okay. For me, I used to advise you do it one by one, because most times the depth that was used to pass a column at the corner might not be able to pass a column at the middle, knowing that column at the middle will carry more load than the one at the corner.
Yes.
So me, I like to do it one by one to like check all the footing, because most times the depth of 300 might pass a column at the corner, but at the middle might now require depth of 350 or 400 to be able to pass. So right now, just click on the
Yes. Yes.
delete, and then do the columns base one by one. Okay. Now let's try that. Yeah, let's try that one now. That one I'm thinking it will be a combined footing because of how close those columns are. So let us try that. If it is not combined footing, then we can move on to that. So insert part base, calculate, square it first. Okay, then okay, that's fine. Okay.
Yeah, it's a 1 meter footing.
Yeah, say okay. Then inside the one say okay. Then inside the one just below it, let's see if there are being like overlapping between them. Once there is an overlapping, we'll now use it as a combined footing. Okay, it will not
Okay.
overlap. They have smaller sizes. Say okay. Okay, now let me just show you how to design for a combined footing. So delete that. Let us assume that that's a combined footing. So you only combine footing when you see that your footing when you have footing
Overlapping.
yeah um like overlapping each other. So delete that too. Let us use that as a combined footing. Let me show you how to do that too.
You should delete this one also.
Yes, delete it too. Let us combine that footing together. So now to combine a column together for a footing base, you have to select those two columns together. The columns together at yeah. Now right click and then you see combine footing option. Say combine, you can see that combine there. Combine. Yes. Click on that. Then say yes. Okay, now right click now and say insert part base. It will not design it at a combined footing. Yeah, insert part base.
Okay.
Okay, now click on calculate first. Now square it first. Okay, that's fine. So it is okay, okay, and okay, and okay, right? Now hold on first. Your size
Yes.
is 1 2 by 1 2, but you can see that the column is almost at the edge of the column. Sorry, the column is almost at the edge of the footing. So at this point right now, you have to now increase your square. You have to now increase your size of your footing. So try to increase that LS. Increase the LS to at least 1.4. Yeah, find that place. Yeah, from there. Okay. Make this place no make this ly to be increased. Let me see. I want it to have a uniform value. Okay, now click on OK first. Let me show you another thing again. No, click on OK.
Okay.
Yeah, OK first. Now you can see that this place they have axial load, moment at X, moment at Y. Can you see that?
Yeah. Yes, I can
Okay,
see.
now most times this software used to use moment to size your footing for you, which is not okay because manual design we used to use only axial load to size footing. Now when you see that your footing size is becoming too big and you see that the axial load is not much, like as you can see this right now, the both of the axial loads is 152.33, which normally a footing of 1.2 by 1.2 can be able to carry it, or 1.4 by 1.4 can be able to carry these two columns based on the axial load. But because there is a higher moment on X and Y, it is now trying to use that value of the moment to size the footing. So once you experience this kind of thing, when you're having your footing very big, you have to go and remove these two moments and use only the axial load to size it. So right now, click on this place called use manual defined load. You can see that option check. Check it now. Then make the moment X and Y to be 0. 0 and 0. Okay, now click on calculate. Okay, now square it. Okay, now because we have a combined footing, let's increase it. Let's increase the footing the size to at least 1.4 by 1.4. Else, this one by one will be able to carry, but yeah, 1.4 by 1.4. Okay, that's fine. Now click on OK because I think it's every checking is okay. So OK and OK it. Okay, you can see that even at 1.4, the footing is not inside the the column is not inside the footing. So at this point, if you still want to use a
Yes.
combined footing for these two columns, you have to increase the size of this footing to at least, let me say, 17 by 17. So I click now and say properties. Can you hear me? Yeah, properties.
Yes.
Then go and increase the size. Just say calculate. Increase the size to at least 17 by 17. Okay, that's fine. Let's see if that will fit in. Okay, that's fine. Now, if the column is still at the edge, you can also increase it. Now, that's just to show you how to increase. But basically, this column, these two columns, they were okay for single footing. But I just use this as an example to show you how to design for a combined footing. Right now,
Yes.
that place where I showed you that if you take off the those ms and my, just now let me now delete that combined footing. Just delete the footing. Let me show you how we got that value. Delete that first, then click on that column again, and then separate them from a combined column. Click on it, right click, and then say remove. Yeah, remove combine. Yeah, click on that. Okay, that's fine. Now click on one of that circular column. Let us insert that column now. Then I'll show you how to get how we got that. Yeah, insert part base. Now click back on the first option, try all combination. Else it will not be able to calculate because okay, click on that first. Now click on calculate first. Calculate again. Okay, square it, then say okay and all that. Okay, now even if we remove this ms and my, we will still get that 1.0. Now I'll show you how to get that. Now remove it first. Go to that use your manual defined load and remove the moments and make it 0, and then calculate. Okay, square it and then say okay. Just say okay. Now let's stop there. Now I don't know if you have do calculator. Let me see your calculator on your screen. Can you hear me? Okay, that's fine. Let me see it. I'm not seeing it
Yes.
here. I can't see it here. Okay, that's fine. So right now, to now check, like I told you before, that we only use an axial load to size our footing. So right now, this axial load we have here is 64.11 kilonewton. So how we do that is the axial load all over the bearing capacity, then square root of that value will give you the size of your footing. So do it right now. So the axial load, which is 64.11, no, 64, okay, that's fine, anyone. 64.11, just cancel, yeah. 64.11 all over the bearing capacity, which is 150, equals to first. Now square that value, square the value. Now it's given, okay, yeah, it's giving you 0.6. All right, that is basically, normally what would have been the size of this footing is around 700 by 700, but because this software has a default size of a footing to be 1 meter by 1 meter, that's why we're having that.
The main answer.
Yeah,
Yeah.
else basically this is the size of the footing, 650 by 650 thereabout, or 700 by 700. Okay, so this is how to know your size of footing. Okay, so let's just now say okay so that you can insert that.
Okay.
Okay, so you can use this same checking to check for any other footing if you want to check how the size, or let me say, if the size becomes too big, you can use that checking to check what is the main outer size. Okay, then Okay, so use the same procedure and insert for all other part base.
Yeah. Okay.
Are you there?
All right. Yes, sir.
Okay.
So I can go on and do the foundations for all of
Yes,
the
for
columns.
now let's do one of the column at the middle. Let me just see what it will give. Let me see the column at axis D, that middle one.
This one, yeah.
No,
On this
not
one.
that one. The column C12. Yeah, let's see that one.
C12. Okay.
Let's see that one. That one looks, at least that one can be up to 1.3 or thereabouts, or 1.2, 1.4. Okay, no. You have to check this place. Try that. It's not work. Yeah. Click on calculate. Square it. Okay, I think this is small bit naturally, so that's why it's not having much and larger this thing. So click on OK. So that's okay for that one. Let's see the cantilever area, the column around the cantilever area. Let's see that one too. The column on the cantilever area. Let me see this column at grid line F. No, grid line F. Yeah, that one. Calculate. Okay, the same thing. Okay, this is what we naturally got. But if you do a larger building, that's when you'll be seeing different depths, different size of footing. Okay, just say okay. Okay, and
Here
then
the only bigger one that we got is this one.
yes, okay,
1.2 by
yes, then
1.2.
that's the highest there. Okay, so this is the next
Maybe
step.
this one can be big.
Which of them? Okay, yeah, let's see that one. Let's see that one.
Maybe column number 11.
Calculate.
It's 1.2.
Okay, that's fine. That's fine. Okay. Okay, it's okay, that's fine. So the same step
Okay,
you
this
use.
one's a
So
1.2.
okay, so this is the step we use for foundation design. So let us see the let me see the 3D view of it before you can finish up the rest. 3D view of it. Go out from this model face. Go out from this model face. Go out from this interface from this yeah.
Okay.
Yeah, from there. Then go to none. Click on none. Okay, that's fine. You can choose to okay. You can choose to change your color of your foundation too. You can change it to either magenta or yeah, gray, dark gray. Yes, that one. Go to foundation. I think is down. Foundation. Yeah, foundation hash. No, not that one. The top one, the upper yeah, foundation. You can use yeah, that gray or that black. Then increase the this thing, the opacity. Say okay, increase it
Okay.
is low, yeah, is low. Make it to be dark, yeah. Dense, okay, that's fine. And then okay it now. Okay, that's fine.
Yeah.
Okay, so this is how we do part foundation. You can, it's like your grid line. Okay, that's fine.
Why is it the column is starting from the base of the pad? Is it not supposed to start at the top?
What do you say? The column.
The column, is it not supposed to go to top of footing?
No. You know that the like the column reinforcement is meant to sit at the bottom of the base reinforcement. You know that?
Okay.
So yeah.
Yeah.
So I think that's why. That's why I happened that way.
Okay.
Okay. So this is how to do your foundation design for a part foundation, basically.
Okay. Yeah.
Okay. So I expect you to finish the same step, finish up the part foundation of what you have. Can you do that?
Yes.
Okay, so I will send you a plan. So right now we are done with this one story building design. The next thing to do right now is to now detail for slab detailing. But this software doesn't
Okay.
do slab detailing very well. Like it doesn't produce the slab detailing very well. So I used to use a manual detailing for slab, because if you use this software to detail your slab and then go and present to your client or to anybody, it will not look nice. But the software details beam and column, their beams very well, foundation very well, and all that. But the slab detailing is not that perfected for this software.
Okay.
So what I used to do is just to take the values for the slab, like the spacing and the size of the reinforcement, and then go and now do my manual slab detailing manually. Okay, so the next stage about entering is just the detailing, and then how to get our uh, how to get our reports, and also transfer all the files back to the software AutoCAD to now begin our detailing. But before then, you have to master this modeling first, and also design. So I'll send you a plan of a
Yeah.
two-story building. So what I'm meant to do once I send you the plan is to, first of all, on the ground floor, you have to do your GA, which simply means just as the thing we did in the afternoon, do your ground floor GA, like, yeah, on your ground floor GA, position your column, panel it, and all that. Then copy your column to the first floor to see the columns, which is if if the floors are the same, but although they won't be the same, because I will like send you a plan that has different where the first floor and second floor and third floor are not the same. Can you hear me?
Okay.
Okay, so you're meant to
Yes,
copy
I
your
can hear.
column onto the first floor, then mark those columns mark the columns which is to be removed. Because if you don't mark them, when you come to this place during the modeling here, it might take you time. So you mark them first, and also go to the second floor too and mark the columns which are to be removed. Then you can now export that your ground floor GA that you've done framing into this place, and then begin your modeling. All right.
Okay.
So, okay,
Yes.
so I will send you the plan this night. So by tomorrow, when we meet, before we begin that, okay, okay, yeah, I'll send it to you. Then maybe before we meet tomorrow, you can finish the GA, then model to the, let me say, if you can model or you can model or, but maybe if you are hooked anywhere, you can just model to the place where you can do. Then tomorrow when we meet up, we will now continue from where you stop. Then also tomorrow, before we begin that two-story building fully, we'll first of all export this file, everything, at least produce like the reports for this for the column, beams, and the foundations and the slab. Then also transfer it back to this software AutoCAD, because there are some settings which you're meant to
Okay.
do too. So we'll do that tomorrow before we now begin fully on the two-story building. But before I come
Okay.
tomorrow, before me tomorrow, you are meant to at least do the GA, then try to model it, at least model to at least to like what you're able to like know, understand. If you can model all, that will be fine. Okay, so any
Okay.
questions so far for the foundation of what you have done?
No question at the moment. Can we, maybe I can just request that you can send me the links for the recorded video so that I can do
Okay,
some referencing
okay,
when
okay, yeah,
I'm practicing on my own. Yeah.
okay, yeah, that's fine, that's fine. Okay, no problem. So you have you so you finish up this foundation design, then I'll send it to you to your
Margin, we
mail,
don't have
that two-story
to.
building now, just
We,
now. Okay,
okay,
okay
so
now.
that we
So
don't have to waste time now going back asking the things that would have been presented. Yeah.
okay, okay, okay. So now, good night. So tomorrow when you are
Okay.
ready, when you are free, just let me know earlier when you be free.
Okay. No, we'll discuss and arrange a convenient time for both of us.
Okay, okay, that's fine, that's fine.
I'll just have to check with the schedule for this electricity.
Okay,
At least
okay,
we do have a timetable. So when there's no electricity, my Wi-Fi is not that good when there's no electricity.
okay. That's fine.
Yeah.
Okay, no problem. So tomorrow
All
we'll meet.
right.
Yeah, bye. Okay, yeah. Thank you, Jesus. Oh, that's a good one. So right now we move on to the next stage at part 2, which is the two-story building design. Okay, that's fine. So if you're ready to hook up to this tutorial for the personal training, I would say you should just follow the link down below this training and join our Ekidel Mentorship Class. Okay, so thank you, and then we'll move on to the next.